The impact of climate change on global weather patterns. Introduction. The Earth's climate is undergoing a profound transformation due to the human-driven increase in greenhouse gas emissions. This phenomenon, commonly referred to as climate change, is having a significant impact on global weather patterns, leading to more frequent and severe extreme weather events, shifting precipitation patterns, and alterations in atmospheric circulation systems. Understanding the complex interplay between climate change and weather patterns is crucial for anticipating and mitigating the consequences of this global challenge. The science behind climate change and weather. Climate change is driven by the accumulation of greenhouse gases, such as carbon dioxide, methane, and nitrous oxide, in the Earth's atmosphere. These gases trap heat from the sun, causing the overall temperature of the planet to rise. This increase in global temperature disrupts the delicate balance of the Earth's atmospheric and oceanic systems, leading to changes in weather patterns around the world. At the heart of this connection is the concept of the greenhouse effect. Greenhouse gases in the atmosphere act like a blanket, trapping heat that would otherwise radiate back into space. As the concentration of these gases increases, more heat is retained, causing the overall temperature of the planet to rise. This warming of the Earth's surface and lower atmosphere alters the way energy is distributed, which in turn affects the complex systems that govern global weather patterns. Extreme weather events. One of the most visible impacts of climate change on global weather patterns is the increased frequency and intensity of extreme weather events. Rising global temperatures are contributing to the following phenomena: heat waves. Climate change is leading to more frequent and prolonged heat waves, with record-breaking temperatures being observed in many regions around the world. These extreme heat events can have devastating effects on human health, agricultural productivity, and ecosystems. Droughts, shifting precipitation patterns, and rising temperatures are causing prolonged droughts in some areas, leading to water scarcity, crop failures, and increased risk of wildfires, floods. Conversely, other regions are experiencing more intense and frequent heavy rainfall events, leading to widespread flooding and associated damage to infrastructure, agriculture, and human settlements. Hurricanes and typhoons. The warming of the oceans is providing more energy to fuel the formation and intensification of tropical cyclones, such as hurricanes and typhoons. These storms are becoming stronger, with higher wind speeds and increased rainfall. Blizzards and winter storms. Climate change is also affecting the frequency and intensity of winter weather events, with some regions experiencing more severe blizzards, ice storms, and cold snaps. These extreme weather events have far-reaching consequences, impacting human lives, economic activities, and the overall resilience of communities around the world. Shifts in precipitation patterns. In addition to more frequent and severe extreme weather events, climate change is also altering the distribution of precipitation around the globe. Warming temperatures are affecting the water cycle, leading to changes in the amount, timing, and location of rainfall and snowfall, what regions becoming wetter. Many regions that historically experienced high precipitation levels are now seeing even more intense rainfall, leading to increased risks of flooding and water-related disasters, dry regions becoming drier. Conversely, areas that were already arid or semi-arid are experiencing prolonged droughts, exacerbating water scarcity and posing challenges for agriculture and human settlements. Changing seasonal patterns. The timing and duration of wet and dry seasons are shifting, disrupting the traditional agricultural and ecological cycles that communities have relied on for generations. These changes in precipitation patterns have far-reaching implications for water resources, food production, and the overall sustainability of local and regional ecosystems. Alterations in atmospheric circulation systems. Climate change is also impacting the complex atmospheric circulation systems that govern global weather patterns. These include jet streams. The high-altitude air currents known as jet streams are becoming more erratic and unpredictable, leading to changes in storm tracks and weather patterns. El Niño Southern Oscillation, ENSO. The periodic fluctuations in ocean temperatures and air pressure in the tropical Pacific Ocean, known as ENSO, are being affected by climate change, leading to more frequent and intense El Niño and La Niña events. Monsoons, the seasonal wind patterns that bring heavy rainfall to many parts of the world, such as the Asian monsoon, are being disrupted, leading to changes in the timing and intensity of these critical precipitation events. Arctic and Antarctic oscillations. The complex atmospheric circulation patterns in the polar regions, which influence weather patterns in the mid-latitudes, are being altered by the rapid warming and melting of the Arctic and Antarctic regions. These changes in atmospheric circulation systems have far-reaching consequences, affecting weather patterns, precipitation, and the overall stability of the global climate system. Regional impacts and adaptation strategies. The impacts of climate change on global weather patterns are not evenly distributed, with some regions experiencing more severe consequences than others. Understanding these regional variations is crucial for developing effective adaptation strategies. Tropical and subtropical regions. These regions are especially vulnerable to the impacts of climate change, including more frequent and intense hurricanes, droughts, and shifts in monsoon patterns, which can have devastating effects on agriculture, water resources, and human health. Temperate regions. Mid-latitude regions are experiencing a range of impacts, such as more frequent heat waves, changes in precipitation patterns, and alterations in the frequency and intensity of winter storms. High latitude regions. The Arctic and Antarctic regions are warming at a faster rate than the global average, leading to the rapid melting of sea ice, glaciers, and permafrost, with cascading effects on weather patterns and ecosystems. Adapting to these regional impacts requires a multifaceted approach, including improving early warning systems and disaster preparedness, investing in resilient infrastructure, and sustainable water management, transitioning to renewable energy sources and promoting energy efficiency, adopting climate-smart agricultural practices, and diversifying crop portfolios, protecting and restoring natural ecosystems to enhance their ability to mitigate the effects of climate change by taking action at the local, regional, and global levels. Communities can become more resilient in the face of the changing climate and its impact on global weather patterns. Conclusion: the impact of climate change on global weather patterns is a complex and multifaceted challenge that requires a comprehensive understanding of the underlying science and a concerted global effort to mitigate and adapt to these changes. As the Earth's climate continues to warm, the frequency and intensity of extreme weather events, shifts in precipitation patterns, and alterations in atmospheric circulation systems will have far-reaching consequences for human societies, economies, and ecosystems. By acknowledging the reality of climate change and taking decisive actions to reduce greenhouse gas emissions, invest in resilient infrastructure, and protect natural environments, we can work towards a more sustainable and resilient future, where communities around the world are better prepared to navigate the changes in global weather patterns. The time to act is now, as the impacts of climate change continue to unfold with profound implications for the well-being of our planet and all its inhabitants.